Hello everyone and welcome to another Fusion 360 Tech Tuesday. This is episode 15 where we're going to learn how to create a flight test foam model. In fact, you'll notice behind me I've got some different things in the background than I usually do. These are actually models my kids and I actually built from FliteTest, and I got an email from one of the people that have been attending these live streams, and he basically said, first of all, thank you. This is from Bob. He said, love your live streams, they're informative. But he was trying to create an assembly using as-built joints, which is one of the things that I showed in an earlier live stream. And so what he was trying to do is to create a foam cowl to go around a remote control airplane. As soon as I saw that this was FliteTest, I was like, oh, I gotta answer this one. This one's gonna be kind of fun. I am not affiliated with FliteTest in any way, but I really do like them. In fact, I'll show a couple quick things real quick with them. This is their webpage, so you'll notice Flight is spelled a little bit different. I've linked their webpage in the description of this video. They also use Fusion. So this is Josh Bixler, and I don't know how well this is going to share, but you can see that they're actually using Fusion to design some of the things and some of the products that they're creating and stuff. So I think it's really cool. I've actually helped a couple of them with some of their quadcopter designs. I'm even out on one of their web pages. So I helped teach how to design stuff in CAD for one of the local high schools, and so they called me Mr. T. So I'm going to kind of scroll through here, and you can kind of see I designed my quadcopter, which I then cut out on my CNC machine, and then I flew it for them, and it has FPV and a camera on it, and so I was able to film their high school campus and all of the students, etc. So I personally, I think FliteTest is a great web page, especially if you're interested in remote control stuff, because they basically try and get people involved with the cheapest amount of investment as possible. In fact, a lot of their plans are made out of Dollar Tree foam board, where it basically costs $1 to cut these foam parts out and stuff. So, so again, I'm going to go back to this email here. So Bob was trying to simulate how to create these, and he sent me a link, and he basically says he wants to sketch it up, fold it, print it, and then maybe make a plug out of it. And I thought this was really kind of cool, because eventually he's going to want to vacuum form a cowl. So this is what I'm hoping to show you guys today. Okay, let's dive right in. Okay, so again, a shout out to Bob for asking this. So he sent me a file, and this is we're going to focus on just one of the parts on this plan, but this is kind of what the flight test plans look like. So you can cut them out yourselves, etc. And so he wanted to fold, basically create this, and here's what the final product's going to look like. So if I go, back to this web page here. They have these build videos on how to make these, and so it basically shows them cutting the part out and then folding them with certain angles. And so he was trying to simulate this in Fusion for his own design. And so you can kind of see they're bending it and they're going to glue it together. I'm going to kind of fast forward here a little bit, and you can kind of see it's going to make this particular cowl, which then slides onto the front of the airplane like so. So that's what we're going to simulate. Okay, so I'll be honest, the first thing I wanted to do was to use our sheet metal module. And unfortunately, we don't have the ability to fold along bends that you can just like sketch onto a sheet metal part. And so I was not able to do this in sheet metal yet. I think down the road, we're going to see the ability to draw lines on a sheet metal part and say bend at that line. So the only thing I could think of was to actually use individual components and join them together using as-built joints. So what Bob did is he got the plans and he added it as a canvas. And I showed that in one of actually I think it was in our last episode, episode 14, where I showed how to create a free-form handle for like a spatula. I brought in an image, and you just go under Insert, Attached Canvas. And so we did that. Then the next thing we want to do is to calibrate it. Okay? So you'll notice up here in the top right of the plans, there's a legend. And so I just right-clicked on here and said Calibrate. And now all I have to do is pick 2 points. So I'm going to pick 1 point there and another point over here. Now I'm going to do another shout out. This is for, I'm hoping I'm saying the name correctly, but I think it's Ayal. Said in my last live stream, when I calibrated, I just picked a small distance. And he said you'd actually be more accurate if you went from 0 to like 10 inches, for example, or 0 to 6 inches instead of 0 to 1 inch. And you're absolutely correct. I love that kind of feedback. I was like, oh, that makes total sense. So I'm going to do that here. So I pick 1 point over here, another point way over here, and I'm going to say that is 6 inches. You'll notice right now it says 5.8. So I'm going to say 6, and you'll see the image grew just slightly. And so now we know that we're calibrated to the right distance. Okay? Now in this example, there's a lot of repetitive stuff, so I'm going to show a couple steps and then kind of jump ahead. Kind of like the take the cake out of the oven kind of shows. So I'm going to come in here and basically create a sketch, okay, on this top face. And all I need to do is kind of zoom in and basically start tracing around. So for example, I might start here, and I'm just going to get as near these intersections as I can. Again, this is kind of more for representation, but you'll notice as I'm moving around, it's actually saying, hey, you're parallel. It's automatically creating those constraints for me. I'm parallel to that other line, which is pretty cool. So I'm going to go ahead and get near there, and then I'll come over here. And basically, I'm just trying to get as close as I can, and I'm tracing over these plans, okay? So, et cetera, et cetera. I would keep going, but I'm not going to do the whole thing. So I'm going to come down here, come over here a little bit. And I recommend, zooming in if you need to. The higher resolution your image is, the happier you'll be. So you can see that it filled in with this tan color, saying that that's a valid profile. And that's this show profile right here. I can turn that on or off. And the next thing I want to do is create lines that go between each of these segments. So I'm going to say line. And I just have to get near, and you'll see that it automatically snaps to where I had clicked. Okay, so I'm just getting near these. And the reason for that is I now have separate areas that we're going to extrude. So you can see instead of one big solid shape, we've basically broken this down into a couple of quadrants, if you want to call it that. Okay, and honestly, I would continue on. I would just keep sketching, and you can see how it catches to those areas. So I'll go ahead and just click, and again, I would spend more time I'd probably be zoomed in a little bit more. But all I have to do is basically trace over these areas, and now you can see I've added these two quadrants also. Okay? So I would do that all the way across. So again, to speed up time, I've kind of done that already. I've left a little area that I need to work on. So let's go ahead and take a look at this, and I'm just going to go ahead and edit this sketch, and I'm going to finish this up really quick. So I'll just grab a couple little points here, and then I'm going to show you how I would go about doing that window that you see. So I'll go there, and finally down here. Now, so here's an interesting issue that I have. As I get near this point, you can see that Fusion's wanting to snap vertically. And so it's not really letting me pick that point that I want. And it's because the constraints are automatically being created. If I hold down my control key while I'm moving, you can kind of see it's no longer snapping to vertical. It's no longer trying to do that vertical constraint. As soon as I let go, you'll see it kind of snap back to vertical. So if you ever want to get out of it automatically doing the constraints, just hold down your control key. Okay, so I'll go ahead and do there, and then finally here. Okay, so how would I do this window with these curved edges and stuff like that? Well, that could be difficult. I mean, I could do arcs and all that kind of stuff, but I'm going to show you a neat little trick. I'm just going to go ahead and trace some small segments. So I'm just going to do a line there. I'll do a line over here somewhere, kind of like this. And I'll go ahead and turn off the canvas so you can kind of see I'm just drawing a couple little line segments. So I'll do the same thing over here, kind of tracing over the angle of this window. And then I'll finally do another one here. Okay. And again, if I turn off my canvas, we can see what I ended up with. Okay. Now I'm going to come in here and use my extend command. So all I have to do is hover over an edge like this, and you'll see it doesn't extend all the way because it's actually lining up with other elements. But watch what happens. If I click there and then I click again, you can see how it's going to the next boundary. So I'll do the same thing there. You can kind of see how it's extending to the next boundary, which is right here. So I can go ahead and, hover over this and just do a couple quick little clicks. And I'll notice there's a little bit of a gap there, so I'll click one more time. And same thing here. I'm just going to kind of extend these in real quick, like so. Okay, if I turn my canvas back on, we can kind of see I now have this sharp cornered window. And I'll go ahead and do a fillet. Now, in one of my previous live streams, I said, don't use the fillet command in Sketch, use it in 3D. And I could definitely do that in this case, but I am going to do a 2D fillet in this example, just because I'm probably not going to come back and change the radius of this, but I do want to show you that you can do it in 3D or you can do it in 2D. So I'm going to come in here and say fillet. I'll click on the corner, and I'm just going to drag until it looks pretty close, and it looks like around 0.4. So I'll go ahead and just click these other corners, and there we go. Okay, so I've now sketched all of these different areas. If I were to turn off my canvas, we can see, oops, I didn't do that last 0.4. Let me go here, say okay. So you can see we have all these different areas. And I'm going to say stop sketch. Okay. Now, so FliteTest uses like Dollar Tree foam board, which happens to be 3/16 of an inch thick. And what I'm going to want to do is to actually extrude all of these regions individually. So they're going to be individual components. So I'd have to type in 3/16 multiple times. So this is where your parameters really come into play. So I'm going to say change parameters, and I'm going to create a user parameter. Okay, and we could even call it, let's just call it foam. It's in inches, and I want it to be 3/16. Now, I always want it to extrude away from me, so I'm actually going to say minus 3/16. And you'll notice it figures out the value for me automatically. But basically what we're doing is creating a variable called foam, and it's going to be 3/16 of an inch thick. So check this out. Now I can come in here, and I'm going to say new component. Now, why am I doing a component? Well, all of these parts are going to interact with themselves or with other parts. So I want to use the joint command, or in fact the as-built joint command, and these require them to be components. So we're going to say new component, and I'm just going to say, let's just call this foam part, and I'll say okay, and I now have a component called foam part. Now, what's going to happen is all of my parts are going to come under here. In fact, I'm going to rename that to make even more sense. I'm going to say foam part assembly. Let's do that. Okay, so now I can come in here and say extrude. How far do I want to extrude? I want to extrude whatever the distance foam is. So you can see how I start to type in foam and it finds a user parameter called foam. And when I do that, you can see that it actually extrudes in the negative direction the thickness of foam. And what's really cool about this is, let's say you don't use Dollar Tree foam board, you actually went to Walmart or someplace like that and you bought some foam from Hobby Lobby or Walmart, and maybe it's not 3/16, maybe it's like 4 millimeters or slightly different. You could just go in and change that variable and all of your parts will change the thickness, and you don't have to go back and edit every single one. So another positive reason why you might want to use a parameter. Okay, now the key thing is I want to make sure that I'm saying new component every time I do this. So I'm going to say new component and I'll say OK. And now you'll see a couple things happen. If I expand open my foam part assembly, there's our first component. You also notice that my sketch went away, but all I have to do is just turn it back on. Okay, so then I'm going to do the exact same thing. I'm going to right click, extrude, how far. I don't even have to type in foam. I can actually just hit this little down arrow and it remembers all of my previously entered numbers that I've done. So I'm going to say foam, new component. Okay, I'm going to repeat my last command just by dragging straight up. How far? I'll say foam, new component. So again, kind of repetitive. I'm having to do this over and over again, but you'll notice that it's creating these individual components. So distance and new component. Okay, and I would just keep working along, and I'll just do maybe 2 or 3 more here, and then I'll jump ahead. So there's no, like, I can't just select all of these. You know, I could do maybe a couple of them, but I want them to be separate components because we're going to be rotating each one individually. So that's why I have to make these individual. Okay. Okay. And then finally, you know, I could do maybe this one over here, but let's go ahead and jump ahead. Yeah, in fact, that's what I did. I'll go ahead and turn off my canvas. I've extruded a whole bunch of these, and we can see all the individual components in here. Okay, so I'll just do these last 3 really quick. I'll say extrude, how far, foam, and again, I want to make sure I say new component. Let me turn on my sketch. And hopefully you know this trick. If you right mouse click, you see the marking menu and you can see this blue radar kind of moving around. And you see this black line. This is what we call a gesture. And basically what that's saying is if I drag straight up, it's going to repeat the last command. If I were to drag to the left, it would undo. If I were to drag down, it would go into my sketch menu, etc. So all I'm doing is right-clicking and dragging straight up, and it's repeating my last command. Okay, so kind of a neat shortcut. So I'll say new component, I'll say OK, and then finally I'll repeat one more time, and I'm going to select this outer region, and you'll see it leaves the window there. We'll come in and say foam and new component. Okay, so I've basically recreated what it would look like if I were to cut this out of their plans. Now, this shaded area here, this is a paper that they fold over to kind of seal the edge. We're not going to worry about any of that in this example because we just want the basic shape. I'm not going to worry about the paper part of it. Okay, so now that I have this, I want to simulate how it would fold together. And because these are components, I can use as-built joints. because the as-built joint allows you to take components that are already where they need to be and create a joint with them. However, the first thing we need to do is we need to pick one of these pieces of foam that's going to be stationary. And I'm going to say this is basically the bottom of the whole cowl. So I select on it, it tells me it's this component here. I'm going to go ahead and right mouse click and say ground. And you'll notice that it puts the little tiny pin icon. What that means is I can't physically drag on this, where I can move these other ones because they're all separate components. I cannot move this one because I've grounded it. Okay? It's stationary. It's what's held in our hand or glued to the table or whatever. So now what I want to do is create as-built joints. So I'm going to come in here and say as-built joint. And what are the two components? So I'm going to say this guy and this guy. Now I want them to be able to revolve. So I'm going to come in here and say revolute. And in this case, I'm going to actually pick the bottom of this edge. And I'll show you why here in just a moment. Okay? So I'm going to go ahead and just hover over this edge. And you see this little, kind of like this little flag. Now, if I hover over faces, the flag is planar to that face. But if I hover over the edge, you can kind of see how the flag is basically kind of rotating around that edge. So I'm just going to go ahead and click there, and we can see how that would rotate. Okay. Now, again, it's not the best example because we've grounded this part, but it was kind of the order that I picked it. But you can kind of see how it's going to revolve around that edge. Now, the reason I picked this bottom edge is because they're basically crushing the foam. And it's kind of hard to explain, but if you watch the video, they're actually coming in and scoring the foam, and that kind of crushes it and allows it to kind of fold in on itself. And so we're sort of simulating that in this example. Okay. Now, I glanced over at the chat. I see a lot of messages, and somebody said some of these parts are the exact mirror. Couldn't you have just drawn half of them and mirrored them across? And actually, a very good observation. I tried that at first, and believe it or not, it is not an exact mirror. They look like they are, but when I went to fold it together, it didn't quite fold together correctly. So I ended up tracing over the whole thing. But in a situation where it is symmetrical, absolutely, I would have only drawn maybe this whole section over here and then mirrored it over to here and then maybe added this last section. So yes, great observation. And I will try and upload the image. I see somebody said, will it be available so I can practice? Yes, I'm going to try and get better at that, uploading the sample models and stuff like that. So I will try and do that for you. Okay, so I just created a revolute joint right there. Okay, and basically we're just going to do that over and over again. So I'm going to say as built joint here and here, and I'll pick this bottom edge. Okay, say okay, and I'm just going to keep working along, basically picking the exact same edges. So I've done these guys. So let's do maybe this guy and this guy, and I'm going to revolve around this edge. Okay, and I'll do just a couple more. And again, hopefully it makes sense why I'm picking the bottom, because we're basically going to crush the foam. So I'm just going to do that guy, say okay. And then I'll do these so you can kind of see how they interact with each other. It's kind of cool. I'll do that guy, and then finally I'll do this guy here. Okay. And again, I would do that all the way across. But what this allows us to do is you can kind of see how I can grab that guy there. You can kind of see how we can change the angle of this. Now we're going to be much more precise. We're going to actually type in our angles. But you can kind of see how these all interact with each other. if I grab that one, it's trying to do all of them. So I apologize. But we're basically going to come in and fold this. Okay. Again, I'm kind of doing the cake in the oven, so I'm showing a couple steps, and then I'm going to jump ahead, and I've already done a bunch of those steps because I don't want you to just sit here and watch me click, 20 or 30 times, repeating the kind of the same command. So no magic or smoke and mirrors here. Okay. In fact, I should have done it the other way. So let's go ahead and I'll just let me see how far. Yeah, I'll do this one. So let me just finish this up really quick. As built joints. I need to do these guys. Kind of rotate so I can make sure I'm grabbing the correct edge. So bear with me. I'll say okay. This guy and this guy. Now, you might notice that some of the flags are pointing up and some of the flags are pointing down. It really kind of depends on which edge I'm selecting. And it doesn't really matter if it's pointing up or down, but when you go to start typing in some of the dimensions, it's going to go positive or it's going to go negative. And that's kind of what the flags are showing. I already had a joint there, so let me yep, there it is. I'll say this guy and this guy. And then finally, this and this. Okay, so there we go. I've added joints on all of those components. So you can kind of see all of those components. I would go ahead and save, obviously, because I've just done a bunch of stuff. But now what's kind of cool is I can come in and use the drive joints command. Okay, and remember, this guy is grounded right here. We can't move him, but the other ones we can. So I'm going to come in here and say drive joints. I'm just going to go ahead and select on this joint right here. And when I start to drag, you can kind of see how it's going to move all of those parts at the same time. Okay, which is kind of handy, which is pretty much how building the foam part is how it works. So I'm going to come in here and say minus 30 in this case. Okay, and I'm going to do the exact same thing over here. We'll rotate this guy, and it needs to go 30. And again, I'm getting these numbers from the actual the assemble video. He talks about how to bend these and what angle to bend them at. So again, I'll do drive joints. I'll grab this guy, and it needs to go 60 degrees. So you can kind of see I could rotate, dynamically drag, and kind of see it sort of snap from just random numbers to like 45 there. And I'll keep going, and it's going to snap to 60 for me. Or I could type it in. Okay. So I'll do the same thing over here. We'll say 60. And I'm just going to kind of keep going along. So I think this one here is 45. So I'm going to say minus 45. And this guy here, oops, wrong one. Let me do that guy there is 45. And then finally this one here, I'll go ahead and rotate, and you can kind of see how we can visually see how these are all going to interact with each other. So I can see, probably around, let's try minus 45, and that's a little bit far or whatever, but that's okay. I'm going to leave it the way it is. Okay, and I might have to come in and edit this guy. So I'll double click on him, and I can rotate this down if need be. Now again, you're going to see that some of these parts intersect, and that's because they bevel the edge. In fact, if I turn on my canvas, you'll see, some of these are marked bevel and all kind of stuff. And I'm not going to go into that much detail because that would just take a lot of time. And it's not necessary for what we're trying to do. And I'm not going to spoil the thunder here, but we're actually going to assemble this and then use this to create an organic cowling that we could 3D print or injection mold or something like that. Okay. Now, if I wanted to, I could maybe like subtract these from each other to get that final shape if I want to, but I'm not going to in this case. Okay. Oops, and I did not mean to do that. Okay. Okay, so let's go ahead and continue on with some of these other ones. Sorry. I didn't mean to redo my undo. Okay, I'm going to come in here and say drive joints. We'll grab this guy here. And let's rotate about 45 degrees in this case. And this guy here. And again, I don't know all of these numbers or whatever, but I think maybe it's 30 and all that kind of stuff. So I'm having to play a little bit. So let's come in here and change that to come back a little bit. So you can kind of see how these all line up with each other. Okay. So I'm just going to do a couple more and then we'll jump ahead. So I'll come in here and say drive joints. Let's do maybe this guy here and make that 15 in this case. And this guy here. And I can rotate that up until it kind of joins up or whatever. Okay. So that's almost 19. So let's just say 19 degrees in this case. And I would do the same thing on the other side. Okay, so I come here and say 19 and fold these in. So again, I'm going to jump ahead so you can kind of see here's what the final shape kind of looks like, and you can see it's pretty close. A little bit of overlapping, but again, you know, they bevel these edges. They're going to bevel some of these edges here. But we can actually see all of these joints. So 45, this one here was actually 53 to make it work. 11 degrees, etc. So here's kind of that final shape. And we were able to do this by just using flat components. Okay, coming back to here, we just basically drew them flat, added the joints, and then folded them up into place. So now we kind of know what the overall shape is going to look like. In fact, if I wanted to create a 3D model, you know, of the whole airplane, I could kind of mock it up with the foam. But what I want to show now is, you know, I have a 3D printer. I want to create, instead of a foam cowl, maybe I want to have a 3D printed organic looking cowl to allow it to fly through the air better. And maybe if it breaks, I can print a new one. So I'm going to show some neat tips. Now this is a little bit different than just how to rotate parts into place. We're kind of combining multiple technologies here. So I'm actually going to use the free form design. So I'm going to say create form, and let me turn off that guy. Sorry. I already created one in here. So yeah, let me do this really quick. I'm going to undo back a couple steps. I'll show you the final product here. So this is what we are going to create. Is this something that looks like this? Okay. Now you're like, wow, how long did that take? Hopefully you'll be blown away on how easy it is to do something like this. Okay. So I'm actually going to delete that out of my history tree or my timeline. We'll turn on our foam here, and I'm going to say create form. Now, to me, this looks pretty spherical, cylindrical, but almost more like a sphere. So I'm going to come in here, and you'll notice we have sphere, and we also have quad ball. And I really like quad ball because it kind of breaks the faces evenly across the top, front, right, etc. of a sphere, where this one is more kind of like latitude and longitude. So I'm going to come in here and say quad ball. I'll just go ahead and draw it. Actually, let me do it on, let me turn on my origin. I'm going to go ahead and, sorry, clicked too many times. Quad ball. I want to put it on this plane right here. So I'm going to click on that plane and make sure I'm selecting it. Otherwise, you can see it's going to try and snap to other faces and all that kind of stuff. So I'm going to say that plane there. And let's just do something kind of like that fully encompasses it like so. Okay? Kind of covers the whole thing. So you can kind of see as I was dragging that, I can still see my foam, but I'm going to kind of just make sure I'm going past my foam a little bit, like so. Okay. Now it's kind of hard to see what's going on, so I might come in here and actually change my opacity control. Let's just do maybe like 80%. And I'll go ahead and move this so it's kind of more centered like so. Okay, something like that. Now there's a really cool command in here called pull. And what this does is it actually moves the vertices to the closest 3D model. So I'm going to say pull, and you see all of these vertices kind of highlight. And I'm actually going to just draw a box around the whole thing, and you can kind of see it snap down. In fact, let me do surface points first of all. So you can see how it took that sphere and it kind of brought it to the underlying shape as good as it could. And you'll notice there's some weird oddities, but it's a really cool command. A prime example, like let's say you're designing a shoe and you kind of have what the inside of the shoe looks like. You can just draw a cylinder and snap it or pull it to the shape of that foot, and it's going to match that. And you can see it's keeping G2 continuities, trying to keep this as organic looking as possible. Now, unfortunately, I didn't get the best result that I wanted, but there's some options in here. And the pull type says surface points or control points. I'm going to change this to control points, and you see I get a much smoother result. It's almost like using control splines. But you can see it's kind of on the inside, but that's okay. It's using our 3D model to generate what this shape is going to look like. Okay, so I'm going to go ahead and say okay. And I'm going to edit this guy, and let's just scale him up. So I'm going to scale him in all three directions until he kind of encompasses the whole thing. Okay. Now, I'll go ahead and turn off the foam, and you can see our shape that we have. Now, I need air to be able to come in. So I'm going to click on these two faces, and I'm going to say subdivide. And what that did was it basically added some more geometry there. And it's, again, kind of hard to see, but it took one face and it broke it down into 4. And now I can come in and say, you know what, let's delete those two faces. And now we're kind of looking into, it's no longer a water type model. And in fact, I want the back to be open also, so I'm going to go ahead and delete those faces. Okay. I could turn on my foam again to kind of help me with my reference. And maybe we grab this edge. And let's just slide him over. Not scale. I'll slide him over. So I can kind of bring him over a little bit. And you'll notice it's only happening on one side. But that's okay. We're going to do something cool here in just a moment. But now we can kind of see what this looks like. Now I'm going to turn opacity back to 100 so we can kind of see what this thing looks like. There's also a really cool command in here called symmetry. And I can pick two faces, and if it can, it will make it symmetric. So notice how this line's kind of crooked. You'll notice how I moved this edge over here, and so the mouth is wider over here. All I have to do is select two faces that look sort of symmetric and watch what happens. It makes the part totally symmetric, and now you can see the cowling is open on both sides. And if I were to make a change on one of these, so I'll say edit, we can see how it would change on both sides. Okay, maybe we grab this edge and we push him in slightly to kind of change that. It's kind of pointed right up here, so let's just bring this down a little bit, like so. Same thing with, maybe I'm just going to delete that edge, hopefully. I'll say delete, and we've kind of opened up the back of the cowling. Okay, and I can see my underlying shape here, so I can come in and just basically tweak with this cowling until I get it kind of the way I want this to look. So maybe I'll grab those 2 points, tuck him in a little bit more, like so. And there's even another command, which I'm not going to show in here, but it's called match. So I could actually match my freeform to an existing sketch shape. So if I knew the exact shape of the back, I could match this to it, but that's on an upcoming live stream. So let's just go ahead and take a look at this. Maybe we bring this guy back slightly, like so, rotate it a little bit. So I have a lot of control over what I want this to look like. And when I'm all said and done, I can go ahead and thicken this. So this is kind of what the final shape I want it to look like. I'll come in here and say thicken. What's the T-spline body? I just select on it, and I can extrude or thicken outward or inward. Okay, so in this case, I'm going to go in a little bit, and let's just go maybe 0.1 inches. You also have different thicken types. We can do a sharp, a soft, or a no edge. So I'm going to do a sharp in this case and say OK. And if I turn off, let's just turn off this guy, you can see that it created a very sharp edge. Okay, which is pretty cool. Or I could, let me go ahead and turn that guy off again, come in and say thicken. But instead of sharp, I'm going to say soft. And what it's going to do is create a nice soft edge, or it kind of like rounds things over. So you'll see, if I kind of come back here, instead of a flat edge, it kind of creates a soft round edge. So, okay. So now I'm going to turn on our foam. We can kind of see how we used that shape to create this cowl. Now, again, I would spend more time making sure it matched the rest of the airplane, which I don't have modeled. So I know that was kind of like going from A to Z really quickly, but what I wanted to show there was how a bunch of different things actually. We brought in a canvas. We were able to use that canvas to sketch on and get our sketches the way we wanted. Then we used a parameter and called it foam and basically said extrude all of these to whatever foam is. And check this out. If I come back in here, let's go to here, and I say change parameters, and instead of 3/16, it's going to be a 1/4 inch. Oops, I said 25 inches. Well, you get the point. It actually extruded it 25 inches. I meant to say 0.25. So instead of 3/16, so let's just go 3/16, and then let's go 1/4, 0.25. You can see how that changed the thickness. Let's make it obvious. Let's change it to 1. And there you go. All of my foam pieces thickened at the same time. And I didn't have to go in and edit every single extrude, which would have taken quite some time. So again, that's where the expressions or parameters really come into play. So we did parameters. Then we did as-built joints. Because all of those parts were where they needed to be, I was able to just say, you know, these two parts, let's put a rotational joint, and we were able to rotate them. Then we used the drive joint command to say rotate at 30 degrees, rotate at 45 degrees, and we're able to simulate how to fold that whole thing together. Once it was assembled, we were then able to use that to create a free-form organic shape. So hopefully you found this live stream beneficial. I know it was a lot of things. Down the road, I will tell you another project I'm working on that I want to share with you. Let me, this is my favorite airplane ever. It's called the Cessna Skymaster. It's a pusher and a puller type design. So you can kind of see it has an engine in the front, an engine in the back, dual booms and all kind of stuff. And these are some plans. I'm going to show how can we go about taking these and creating an exact 3D representation of this model. So that's down the road, but keep an eye out for that. So again, thank you everybody. I hope you found this live stream beneficial. Thumbs up, thumbs down. Leave some comments in the comments field on topics you'd like to see. Again, a shout out to Bob. Thank you for sending me this email. Hopefully this answered your question, and hope to see you all on a future live stream. Thank you.